Hello guys, my name is Abdul Ali. I'm from Pakistan and you are watching my IoT project which is Smart Traffic Signal. So let's discuss what we are discussing in this slide. So first topic is the problem statement. Why I picked this problem and what the work already done in the past and what I am proposing. Especially I am proposing a very bigger idea, and for more very specific part I will work in this course. So the second step, we will discuss about the technical details, for example the data structure, the implementation, and then we will discuss about how our backend service processes the data, and then we will discuss how I visualize the data of this proposal, and in the end of course the possible improvements that we can improve. So let's start with why I picked this problem. Because of the traffic congestion, I belong from Pakistan and we had a lot of traffic signal issue. So the first cost we have to buy by the traffic congestion is the fuel, of course the money, and then the time, and the very important thing is health, which will cause in the form of climate change, which is very crucial. So then what are the main causes? Let's discuss a scenario where we have a different signals with a different number of cars. For example, this scenario, and in the traditional traffic signal simulation, not simulation, traffic signal distribution, we have the equal time for all of the signals. Either they have less traffic or more. So this is of course unfair. So what is the solution? The solution should be dynamic input of congestion or the traffic to calculate the dynamic time allotment. And so the solution should be affordable, effective, and efficient, also optimized. So let's discuss the solution we had in the past. The first solution is based on the IR sensor, which basically communicate with the other signals and solve the same problem. But there are some problems in the solution. The first one is the cost of the sensors. The second thing is the sensor range. The third thing is you have to you have to buy the cost of the sensors and the maintenance. Least and the last, the resources that you need to monitor that system. Let's discuss the second solution. I picked the video from the internet, which basically they implement this solution, which is based on magnetic loops. So basically there is a magnetic sensor in the road, which basically notify to the traffic management system, and the traffic management system will get the result of how much time you have to allocate, and the rest of the signals are synchronized. So there are some how this solution work. Of course, as I explained, that there is electromagnetic coil in the road or in the surface, basically which detect the density of the load and then notify to the controller, and the controller will notify to the traffic management system, and the system will get the result towards the signals. So basically there are some problems, which is the road repairing, of course, the installation cost, the range of the coil, and high maintenance. And there is one more, that this solution is not suitable for heavy vehicles. So there are some patches after the installation, which is not good. So my proposal is to use the surveillance camera, which is already installed in the just top side of the traffic signal, as you can see. And the camera will take the pictures and send to the traffic management system, and it will calculate the suitable time for this track, for this signal, for this lane, and it will notify to the traffic signal. So let's discuss the previous scenario. As we discussed earlier, we have four intersection with a different number of cars, and the camera took the images from each side and sent to the server, and server detect the number of cars on each side. As you can see here, each side we will get the exact output of in terms of cars, so that we can easily calculate by this input. So that's how we can dynamically assign the numbers. I'm just giving an assumption. For example, we have one car, so 5 seconds, one truck for 6 seconds, then 4 cars for 15 seconds. It's totally based on the assumption. So it just I just need to describe the idea. So of course the time region should be optimized and more improvable. So let's start with the architecture of this project. The first device is used as the surveillance camera installed on the traffic signal, which basically take the picture and send to the microcontroller. Maybe it's a Raspberry Pi or any other microcontroller. If we want to process our image on the edge computing, so maybe we can use the OpenCV on the microcontroller, but it is more suggested to use the machine learning or the major processing on the server side. So for the assumption, we just use Azure as a backend service, and more specifically blob storage for storing the images and the data. Also, we use the CDN network just to provide the data on all over the world. Also, the caching service to access quickly, and for the image processing, we propose to use incognito service or Azure cognitive service, which is very quick and very smart for the image processing task. Then the server will respond to the microcontroller as a result of how much time you have to allocate, and the traffic signal will appears the light according to the time. Also, the server push the data towards the traffic monitoring system. In our case, it's UV So just let's discuss how I propose my project according to this architecture. So basically, for the simulator for the traffic signal, I just create a traffic signal simulator. The stacks are HTML, CSS, JavaScript, and the nodes node.js, and also the MQTT. So basically, Node.js uses the MQTT to send the data from the simulator to the server. So basically, the simulator takes some pictures as input and then send to the server. And for the backend, for now, I just use the local server, my PC, with the Python script. Basically, it's a server of MQTT, not the server. It's a basically subscriber in that case. Also, the Python script use the file stream to store the data, and then MQTT to send the data. Also, machine learning, a small machine learning model to basically detect the number of cars. Also, when the processing will be complete, the server basically push the data towards two sides. The first to the UV dot, and the second is the traffic signal or the simulator. So just let's skip all of the details of the data structures and let's follow from the how the data structured while sending the request. So when the simulator sends the request towards the server, basically it just sends the array of the signals. In each object we have two attributes, the signal, like the bottom, top, left, right, which signal we are identifying. So basically it is the identifier. The second property is image, which basically showing the exact scenario of the traffic signal. So server receives this data and process. After the processing, it will send the result in the form of the time, in the form of this JSON basically. So exactly we have the same identifier signal as identifying which signal, the result of which signal. The second attribute is the number of cars it detects. The third attribute is empty because we don't need the image in the result. The fourth attribute is allocated time, how much time the bottom signal has to be allocated, and then the priority. I will discuss the priority in the end of the in this slide. It's the same case with the UV dot, but with the different data. So we have top, bottom, left, right. These are the four attributes, and the values are integer, plain integer. The integer are basically the allocated time for each dedicated signals. So I'm not giving the complete description here. Let's go to the code and see how it is working now. So basically, this is my simulator as I described earlier. So I want to show you my logs so that you can also follow what is going on. So basically, first I connect with the test.mosquito.org with the port of 8080, and for publishing the topic I use save image topic. So as you can see here, not here, sorry, here, the simulator and the backend service use two topics. One for publishing the data, the second one is receiving the data. Or you can say, in the first case, the simulator is a publisher because it will publish the images towards the backend service, and in that case, backend service is a subscriber. But when the backend service processes the data and it will send back in the form of result, in that case, publisher is a backend service and the subscriber is the simulator. So, and there are two different topics also. So let's just connect with the Mosquito server. So here we are connected, and now I have to run the backend service, which is already running. So it's just a Python script. So I restarted so we can on the same page. Now I have to upload some images in the form of as traffic signal. So the simulator is acting exactly as the traffic signal, and the camera took the images and now sent to the server. As you can see, server received the images and it downloads the image and delete the images. We will discuss the complete backend process, how it is working. But here, as you can see, the traffic signal, the backend service sent to the data to the simulator, and the simulator simulates the small cars and the timer. So basically, the timer runs in the priority wise. So the first timer, the highest number of allocated time runs first, and then the second highest, and then the third highest. And as you can see, the previous signals are now closed, and after that, of course, the last one. So now we have the initial state again. So as you can see here, in the client side, in the simulator, we receive the data in the form of array, and as I described earlier, in the exact form of the JSON data we discuss here. So let's jump to the UV dot and let's refresh the page. I hope it will retrieve my data, because sometimes it is very slow. As you can see, one table, one widget is still uploading, but as you can see, the other we have the allocated time of 5 seconds for the bottom, as I uploaded the same images and number of times are same. So you can see the different representation of the data, but still you can use this data to analyze the rush hours on the traffic signals on the different area of rush hours, so that you can remove the congestion before that rush hours. So let's discuss the code flow of this project. We have the Python service which acts as a backend service, and the first step of the Python is to connect with the Mosquito server, and then connect with the UV.dot server, and then subscribe the save image topic, which basically used to send the data from the simulator to the Python script. Then we have some events from the MQTT service. For example, on message receive, when we receive the message from the simulator, then we have few steps to be done. The first step is to parse the data, to parse the JSON data from JSON to JavaScript. And then for each signal, as we discussed earlier, the simulator sends the array of the different signals data, which basically have the images. So for each image, or you can say for each signal image, we proceed these steps. The first step is to parse the data into image. Basically the data is in the form of bytes, as we saw earlier, so we have to convert the bytes data into the image. Then this save the image, which we basically parsed before, in this format. So basically we have signal, then the direction of the signal, and then the time it saves. We have 4 images as we have 4 signals in that case. Then we use the machine learning algorithm to detect the cars and send the images to this particular module. So basically, when we have the number of cars on each image, we calculate the allocated time for each signal and then publish the result towards the mosquito, as we are using the traffic signal simulator, and also the UV dot to monitor the data. Now let's discuss how the image processing work. I'm not going deeper, but it just the surface information how it is working. So first we import the CSV2, and then we have a function which is basically, I already mentioned in the previous slide, the detect car, which take the images. Basically this function load the images from the file directory, and then we load the classifier, which basically use the XML car module, which is already pre-trained. I just take it from the GitHub, so you can also do it. Then I read the images as I described earlier from the file system, and then as we know, the images are in this form. The first step of this whole detection process is to change the color space of each image, and then detect multi-scale like multicolor spaces. Then return the number of objects it detects. Basically it is the outcome we need from this whole module, the number of objects it detects. So basically we return the length of the object found, and it will be used in the previous slide, in the previous part here. So I hope you understand now. So when we how the time allocation works, it is a very basic concept that first row gets 5 seconds. It's just an assumption, so you can change this algorithm. So I propose a very basic algorithm which is allot the maximum time to the first row, because it will take few seconds for the first row cars to start the engine and accelerate the car. But for the second and onwards, less time, and we should have to set the minimum threshold for each row. So it's just an assumption, or you can say a very simple proposal. You can improve it in the future. So in the end, let's discuss the future improvement that we can do. So the first is we can detect also the emergency trucks, car, and every emergency services to give the prioritization. Also, as I described earlier, that we can analyze the rush hours and the routes so that we can remove the rush from that routes. Also, we can connect, we can create the network of the traffic signals so that every signal know how many cars he will receive, or every signal will throw the information that how many cars I send towards you. so that they can manage before the critical situation. So time allotment will consider the congestion at the next possible routes. So for example, if I pass 100 cars towards south and east, so that I can inform those signals that, hey, you will receive some sort of congestion in few hours or few minutes, so that they can manage before those critical time. Also, of course, there are some possibilities to improvise or improve this project, so that it is open source. You can find the links which I use in the project. Also, you can find my project, my backend service, my front-end service, also my simulator with this presentation on GitHub. So I hope you can understand easily by watching this presentation, and I hope you understand this topic very well. Thank you so much for watching this video.